Hello. Say it's time for another episode of Gears of Resistance. Ready?
It's not time for another episode of Gears of Resistance.
Yay, teenage years. Alright, so this week we're jumping out of the workshop. We're going to go up into the laboratory. We are going to play around with the OtherMill Pro. It's a CNC machine that does some very fine milling specifically for circuit boards. So we're going to fire up Eagle CAD. I'm going to show you the whole workflow that I've learned so far on how to make a circuit board. Oh, and one more thing. We also got our Hobby Lobby down here in Southern Maryland. So we're going to go take a tour of the new Hobby Lobby. I'm excited. Alright, so let's jump into a quick little tutorial on the Eagle to OtherMill workflow. If you don't have Eagle already, you can head over to Autodesk and download. There is a free version. Basically the limit is you get 2 schematic sheets, 2 signal layers, and the board size 80 square centimeters is the maximum you can do. But it is available for Windows, Mac, and Linux. So and there's tons of libraries out there, and we'll talk about that in a second. But to get started, yeah, you can go ahead and download the again, Eagle from Autodesk. Once you've downloaded, got it installed, then we'll head over to the Other Machine Company's website, and they have a pretty good tutorial walking you through a lot of tools actually. And so, you know, if you're not a fan of Eagle, you're probably maybe a fan of KiCad or maybe Altium and their software. Basically, you can get, if you can get to a Gerber file, you can also use the Other Machine. It's just, as you'll see, it's just ridiculously easy if you're using Eagle and you get a board with their board file. So anyway, the other thing I want to point out is if you scroll on down, and I do encourage you to read all this stuff carefully. It is good little nuggets of information on your design. But if you scroll down here, you'll notice they have their design rule file. So you can download some pre-made design rule files that I think there's 4 of them. Basically, if you're using a 1/32 inch end mill, of course we lose Wi-Fi. Or if you have a 1/64 end mill, basically the design rules will sit there and say, hey, depending on what size of that end mill, are your traces too close together, or are your traces too small? Can they even mill it out? It just gives you one extra check in Eagle to make sure that what you've designed is something the other mill can actually isolate, do the isolation milling on. So again, we'll put links to everything on there. The other little stickers I threw out for Eagle is both Adafruit and SparkFun have a repo on GitHub with all their the parts they use. So you can basically clone this to your desktop, keep it up to date, and you'll always have the most current components that they use. The nice thing is, these are things that are probably, parts that are very easily sourced. They are parts that probably are, relatively inexpensive, and you'll have you'll have the schematic symbol. You'll have a layout for the PCB, so you don't have to go hunting for those. But if you do have to go hunting, let me also point out there's 2 other tools I kind of throw out when I'm doing any sort of circuit design. One is Octopart and their common parts library. So again, if you scroll down to some more of the more like voltage regulators, right? If you were to go onto Mauser or DigiKey, there's tons out there in every configuration, every different package type. this just kind of helps you know, okay, these are the ones that are, again, common, that are used frequently, which means, again, they should be easily sourced and they should be relatively inexpensive. You're not, picking out this really, unique package that's going to cost you $5 a component when something that costs 37 cents a component will do the same job. So I'll check out this site too, over at Octopart. And then the last thing is SnapEDA. So again, if you are, if every now and then you probably have a kind of unique part. So if you have something that you can't find in the standard libraries that come with Eagle or the Adafruit or SparkFun, or I think Seed Studio has one too. If you can't find a part, especially like the footprint for the PCB, check out SnapEDA. You can search the part numbers, and chances are you'll be able to find someone's had that issue before and they've got it drawn up. So that's another little trick that I use to do my designs. So those are the tools that I use. Let's jump on over into Eagle here. So minimize this, and let's go ahead, and we're going to do just something real simple. Not here to do circuit design, for high speed, digital kind of really fancy circuit that requires a lot of technical know-how. So let's just say test project. Yeah, there we go. And create a new project. Let's go ahead and create a new schematic. Let's blow this up. All right, so first things first. Again, if the first time you run this, you have to tell Eagle where the libraries that you've added. So if you've added the Eagle libraries from Adafruit or SparkFun, you have to tell it to use those first, and then they'll show up here in the parts selector. So let's just do a real quick little LED circuit, nothing too fancy. Let's see here. We'll just do surface mount. Let's see. You know what? Let's even just do through hole so we can show how easy it is to drill through. So can I do? There we go. A 5mm. So we'll do a 5mm red LED. Post that. All right. Let's go grab a resistor now. Let's see here, SparkFun resistors, and again, so roughly, if we're going to do this with 5 volts, then probably a 220 ohm resistor is going to be fine. Again, point here is not to really do circuit design. It's more we're trying to show how to do. That's a surface mount. We could do surface mount, but I want to try to do some through hole stuff just to show you how well the OtherMill will drill your holes for you. That was always a pain in my butt with my my other attempts using another CNC machine as well. Like, I got it to mill the traces pretty good. I never really got it to do drilling the holes accurate. Let's go to Adafruit for the here. And we'll go down to R for resistors. All right. There. That should be fine. So we'll put the resistor in here. We have the LED. You know what? Make it a little bit more hard difficult. We'll do 2 resistors and 2 LEDs. Boom, 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 boom. Cancel. Let's copy. There we go. All right, and let's go ahead and let's see if Adafruit has like a battery holder, like a little coin cell battery or something. Actually, then it's only going to be, what, 3 volts? That should still be fine. Battery B, A. Oh, I saw it. Coin cell. Dun, dun, dun. Oh, that's a surface mount. Well, we can do let's do a surface mount for the battery. All right. And we'll throw a little switch in there too, just to make this something that's sort of useful. Maybe you could like throw this behind, like if you made like a little name badge for yourself or something. All right. Through the magic of video editing, I'm going to head and flash forward to the circuit. So we've got the battery here. It's going to go through a little switch. Then the 2 resistors will light up. And then back to ground. So with the schematic done, let's go over to the board. Yep, we want to create a schematic from the board. And I think the last time my problem was, for some reason, having it fully blown up was giving me some issues. So anyway, here we go. So we're going to take the battery and put that kind of towards the side so the battery can slide in. Then we'll take the LEDs, the switch, and that's weird. There's 3 resistors. So what happened? Let's go back to the board. Let's go back to the schematic. And it looks like we accidentally... Yep, so let's go ahead and delete this one. And clean that up here real quick. Alright. Save that. Switch back over to the board. There we go. Alright. Resistors. LEDs. And the switch. Alright. I think... Do we have that? I think we have that right. It looks right. Boom, boom. Alright, so let's go ahead and bring this all a little bit closer together. And again, this isn't really meant to be a board layout demonstration. It's more meant to be a workflow demonstration. Let me actually, let's make this 0.005 inches. And let's go ahead and then shrink this down. Now when you do like a circuit board that you're going to send off to get, like say you're going to send it to Osh Park to get made, you can do things like you know, make the entire copper layer like the grounds. I think when you're milling out your own circuit boards, that tends not to work as well. I think you get greater chances of shorting things out. So I route my ground as a trace versus relying on like a ground plane. You might, again, if you're going to send this out and actually get this board made at a board manufacturer that's going to do, you know, quote unquote the normal way of making a circuit board, you might change this up a little bit. This is, again, if you're going to do isolation milling and taking a you know, a blank copper clad board and then, you know, using the end mill bit to cut your traces into it. Anyway, so I think that's good. Let's go ahead and zoom this in. Now again, I've got it set up right now, or my machine has a 1/64th end mill in it. So let's go to, where do I keep my OtherMill design rules? And here we go. So we're going to use the 1/64th bit design rules. And apply that. And we're going to get errors right now because we've done nothing. But everything looks good so far. At least the pads, we know the pads aren't anything crazy. So let's go ahead and start routing our traces. I'm going to bump this to a, let's see here, 0.032. Yeah. Let's see. I'm trying to remember what I've been using lately. I think that will be fine. Let's see here. Boom, 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 boom. Boom, boom, boom. Oops. Alright, let's save this real quick. Run the DRC on it. No errors. So it says, yep, I can trace 0.032, that's inches, right? I have that in inches right now. Yeah, inches. Okay. So let's go ahead and just finish routing everything here. Boom, boom, boom. Again, like I said, we're not. This is nothing meant to be fancy, complicated, crazy. It's simply meant to show the workflow. I can type here and then go from here. It doesn't really matter. And then we'll go to here. No, I didn't that catch, sure. And then we'll just and I just like to be a little extra careful on my stuff. Let's short anything out. Is there a risk of shorting? Don't think so. Why don't you take? Boom, 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 boom. Save. All right, let's do the electrical rules check. Missing junction. What does it say? Missing junction in net. Show me that one. What am I missing? Yeah, no value, no value, no value. Yep, but these are the ones I'm concerned about. Why does it think that the junction is missing on net 1 and net 7? Alright. Let's rip these up one more time just to make sure. Alright. Alright, save, tools, ERC. It still thinks those nets are not complete. Alright, I think it's just being overly sensitive, so I'm going to go for it and say I approve all. Alright. Let's now run the DRC and check. No errors. And oh, wait a second. Let's see our rat's nest here. Nope. Okay, so we've got all the air wires are done. I'm gonna hit File, Save again. Let me make sure, where did it save it at? File, Save As, Test Project, .board. Okay. All right. So we're going to go ahead and swing on over to the OtherMill software. And we are going to basically go ahead and say we're going to do a single-sided board. This is all we can. One thing we will probably want to check is the thickness. So every time I cut, and I'll show that over there. When I cut anytime I mill, I'll take my calipers out and just measure the thickness of the board and adjust that. The placement, this is Z-axis offset 0.003 inches. You're actually accounting for the thickness of the double-sided tape that you're going to use to hold it down. So that's what that is, kind of like an average. I don't change it, and it seems to work for the Scotch brand double-sided tape. I'll show you. All right, so other than that, let's go ahead and let's go to, where was it at? Test projects, test, and again, here's where the magic really comes in. Is I simply hit open up my board file, and boom, there is the circuit. Let me turn off. I'm not going to cut out the. So anyway, let's go ahead and zoom in and see what are these little red errors. So if you notice, when I zoom in here, it's over here. It says messages. Marked areas need a smaller tool. And then we look up here and go, oh, wait a second. 1/32 inch flat end. When we did our design rule check, we used a 1/64 end mill. So if we tell it, hey, use the 1/64 end mill instead, and now the errors go away. So now if you notice, we'll have, this is where the battery, the coin cell battery holder goes. And this will be the positive terminal. It'll feed to the switch. So this will be a surface mount switch that will lead over to the 2 resistors, to the 2 LEDs, and then the LEDs come back to the ground pads on the battery. And that's it. That is all the processing that it takes. Now, like I said, I cannot really describe, and maybe one time I'll do a video on, I've done a blog write-up about my process before. It probably changed a few more times since I wrote that, but the amount of time it would take me to get to this point in some other design tools, other hardware, to have something like halfway as good as this, something ready to send to my CNC machine to mill. I mean, I'm not kidding. Literally an hour, if not hours, because there's so much rework. It would be, oh, wait a second, it doesn't quite look right. Let me let me go back and redo my Eagle file, and then every time you go back and you redo the Eagle file, the board file, you've got to redo that entire workflow. Whereas here, if I said, oh, wait a second, I don't like this thing real quick, let me close this out, and let me say, hey, you know what? Let me, I don't like the fact that these two, I want this resistor to come down lower. So we rip this up here, rip this up here. And this is just, again, just show you how ridiculously easy this is. So let me say, hey, look, I'm going to change where I put this resistor at. I want it a little bit different. So let's save. Let me go back and route it again. You know what? I wonder if I wasn't quite getting the pad. And that's why it was giving me that error before. Alright, so I hit save again. So basically I went in, I changed my board file, Before, I would run through, like, I'd export an image file, I'd have to convert it to an black and white, make it SVG. You can't even, I can't, like I said, I'm going to just save everyone the agony. I just go over now to OtherMill, go back in, open the board file again, and boom, change it back to the 1/64th end mill. Now, you notice the resistor's a little offset. The amount of time this thing saves is huge. Alright, so that's the design process. To really prove that this whole thing works, we're going to go ahead and I've been designing on my desktop, and then when I actually I put the files into my Dropbox, sync it to my laptop that actually runs the CNC machine, and basically I do the same thing. I'm going to open the file up in OtherPlan and basically tell it to mill, and it's done. So let's go do that. Alright, so this is the OtherMill right here, and then down here I've got a laptop that's also running the OtherPlan software from OtherMill, and basically there's really not much to it. I've already had it calibrated, so I've put on the little fixturing plates that helps makes mounting double-sided circuit boards real simple. But again, for this one we're only doing a single-sided. So again, the one thing you've got to check every time, even though it doesn't change much, take your calipers and there's zero this out. Check the thickness of your board. I kind of like go around all four sides and then kind of like average it out. So like 0.063, 0.063, 0.062. So right now it's at 0.063, so it's pretty good. You'll want to verify that. And then again, the Scotch brand yellow double-sided tape, permanent tape. I take usually like 2 or 3 pieces, put it on the back side here of the board. Well, that's probably impossible to see, but it really holds well. I've never really had a problem. And then, so the nice thing with the other machine, you just pop off the little plexiglass front. For single-sided boards, you'll stay to the left side. Double-sided boards, you'll do the top layer on the left side, and you'll flip it over. You have to change out the double-sided tape, and then you'll do the bottom side flipped on the right. The little fixturing thing, absolutely critical if you're going to do double-sided boards. But for right now, we'll go ahead and abut this to the bottom and to the left side, and then just press it down, give it a little bit of a push. It's really solidly made, the machine, so you don't really worry about hurting it too bad. And then I'll take this off here in a second and put the plexiglass back on. I think that's pretty good. It's really critical if you're doing double-sided boards, not so much for single-sided. Although I will say that what we'll probably end up doing is we will switch this over to do the holes. So one thing I do recommend is, because it doesn't drill all the way through with the holes, even for single-sided boards, that you go ahead and flip it and do the holes on the double-sided board too, or on a single-sided board. So we'll go ahead and close this back up. I really like the light inside. The lighting inside helps, so you can see actually what it's doing. These are all smart. It won't start up unless it detects that all the doors are closed. I always keep my little shop vac close by to suction out when I'm done. And that's it. Other than that, I think we're pretty much set. I've got the board file laid up in here. I'm going to tell it to go to the top side. And let me just take this off the mount here first. Alright, so again, laptop USB cable runs out into the back of the machine. DC power brick goes out back into the machine. That's the only 2 connections you need. I'm assuming in a future version they're going to go wireless, but for now, everything's set up. Again, change your thicknesses as needed, change your the board around as needed, change the end mills, whatever end mill you're using. And then with that, we'll tell it to go ahead and get started. Again, there's the board in there. Let's see, we'll tell it to home the machine. Let me zoom this out. Okay, so it's going to go ahead and home. I'm going to go ahead and here. It's basically figuring out where it's X, Y, and Z, where it is in X, Y, and Z. There goes the Y to the back. And then through your end mill, it's conductive, so it'll actually touch the aluminum plate and figure out the Z-axis as well, which is pretty cool. Alright, so with that, it's honed, and I think we can go ahead and tell it to start milling. So we'll hit mill. Alright, 164. Alright. One thing, it does give you a fairly accurate guesstimate on how long it's going to take. Alright, so it's finished up the routing of the traces. Now it's going to go and drill the holes. Voila! So let me go ahead and put this back up here. Alright, let's go ahead and see how it did. We'll pull out the other cool thing, you can tell it to move it basically to the loading mode, or the loading position, so it's easier to access. One other thing you probably want to keep around is a little scraper. This will help get the board off. Again, there's a side panel too. There's another one on the side. And then just come in here and kind of pry that loose a little bit. It doesn't take too much, but as you can see, let me turn this light off up here. Oh, no, maybe you need that one on. I'll take a picture, maybe that'll be easier. But the trace quality is just unbelievable. And actually, I think this one, the holes drilled pretty well through, so I don't think we have to reroute. Flip this one over. Just note that sometimes, even if you do a single-sided board, that the holes don't go all the way through, so you do want to flip it and have it drill the holes from the backside. That's pretty, compared to, again, what I'm used to with previous efforts and tools. This is night and day different. Here we are at, where are we at? We're at the Hobby Lobby.
I can't even see.
Ready? Alright, so I'm going to kind of give a quick 1-minute review of the Hobby Lobby. We haven't had one down here, and I've only been into one, I think it was quite a few years ago. So my initial impressions were, it's not really a hobby store. I mean, a lot of stuff is pre-built. You know, it's more of a, there's a lot of it is just like the home decoration is probably the majority of it. in the back there is your normal, model making, arts and crafts, kid science, paints, markers. Then of course there's the fabric section, and that was pretty massive and for knitting. But overall, I wasn't getting the hobby vibe. It was more of like the home decor lobby more than anything. Maybe it's just me as someone who, the maker ethos is burned into my head. I would like to see a store that was more geared to real making, real projects, real DIY, and I just kind of didn't feel like the Hobby Lobby delivered on that. It's in terms of the stuff that you can actually use to make, Michaels has probably got quite the selection. So if nothing else, hopefully there'll be competition. But overall, it was a decent experience, I guess. All right, so that's my 2 cents on Hobby Lobby and how it compares to other stores like Joann's and Michael's. Again, it's great to have competition. It's great to have multiple avenues to go down when you're trying to do a project and it's 11, the 11th hour, and you're running out of something. You can, run down to the store and hopefully have something. So, the home, yes, they've got a wide selection of home decor stuff, and comparing, when you contrast that with the name of the store, which is Hobby Lobby, maybe I'm a little too critical, but is what it is. One thing I wanted to also roll out with just this real quick, I showed a really basic, circuit board design for the OtherMill, but I wanted to show like a project I did here recently for a client that uses the particle IO photon microcontroller that has a really robust Internet of Things, cloud, whatever you want to call it, back end that makes it real easy to make an Internet of Things products. And this little light sensor that converts takes the light, and then depending on how bright it is, it takes a 3-volt or 5-volt signal, and it varies the square wave, and varies the frequency of that square wave. I think it keeps it at a 50% duty cycle, but anyway, just wanted to point out, there we go. So, the circuits, you can do some pretty cool things with the OtherMill. The whole idea of in my little shop here, we don't do, we're not just this electronics design, we're not just the software design, we're the whole product. So being able to make a custom board in-house and then turn around and take the Eagle file and because it's both owned by Autodesk, now you can take that and throw it into Fusion 360 and make an enclosure for the mechanical aspects of the board, and then 3D print that on your 3D printer. So the idea of doing the full stack production of a product is pretty cool. Again, there are way cheaper options to make your own circuit boards. Chemical etching is a perfect, viable solution. There are other cheaper CNC machines you can buy off eBay, $200-300. I would just recommend. It really comes down to, for me, it's more of the workflow and the speed. So as someone who's doing this, trying to do a business out of this, being able to quickly iterate fast and make a board fast and be able to have as few steps involved, so that I can reduce errors, and B, my time is very valuable. And a lot of times I do fixed rate, kind of agreements. I say I'm going to build this for you for X dollars, and whether it takes me 5 hours or 10 hours or 20 hours, so I'm very much invested in getting things done as efficiently and quickly as possible. So being able to go from Eagle, hit file, basically file save that same board file, put it into the other plan, mill it, and then take that board and get a 3D model of it and throw it into Fusion 360 and be able to build out a physical enclosure around it, and then send that off to the 3D printer. It's huge. It really is. So anyway, with that, I'm going to shut up. We're going to try to get ready and record another episode of Steam Power Podcast 2. So the work goes on. I just want to say thank you all very much for watching. If you've got any comments, questions about the OtherMill, or you got things about workflow, feel free to hit me with a question down below, and I'll try to answer them. But with that, thanks y'all very much for watching, listening, and until next time, stay quirky and keep it steamy. Thanks for watching.